Hi guys, welcome back. So today we are going to start lesson 8.4. I wrote day 1, but it's actually only a 1-day lesson, so I can erase that. Oh, let me erase that real fast. Okay, there we go. So it is only a 1-day lesson. Okay, so I have the board set up for us to jump right into the notes. First thing I'm going to talk about is partial sum. Okay, partial sum, the sum S sub n for the first n terms of an infinite series. The partial sum of an infinite geometric series may approach a limiting value. We're going to talk about that in the first example. All right, so for the first example, it says given the infinite geometric series. Notice I'm calling it a series, not a sequence, because I'm finding the sum of the terms. All right, and infinite because it goes on forever. All right, so it says find and graph the partial sums, S sub n, for n equals 1, 2, 3, 4, and 5. So what is that asking for? It's saying find the sum of the first term of the series, then find the sum of the first 2 terms, then find the sum of the first 3 terms, then find the sum of the first 4 terms, and finally the sum of the first 5 terms. Then we're going to describe what happens to S sub n as n increases. Okay, we're going to look, is there a limiting value? All right, so step 1 is to find the partial sums. That's S sub 1, S sub 2, and so on as I just described. Okay, so S sub 1, the sum of the first term is just 1/2. S sub 2 means find the sum of the first 2 terms, 1/2 plus 1/4. You can get common denominators, make this 2/4 instead of 1/2. So that's going to be a sum of 1/3, or excuse me, not 1/3, 3/4, or 0.75. We'll turn these into decimals. That's 0.5. Okay. Then the sum of the first 3 terms. So now I have 1/2 plus 1/4 plus 1/8. I would get common denominators of 8, so this would be 4/8. Okay, this would be 2/8. So I'm going to turn it into a decimal anyway, so I'm going to say it's approximately 0.88. Then I'm going to find the sum of the first 4 terms. So 1, 2, 3, and 4. I'm going to actually write them all with common denominators. I'm going to have common denominators of 16. So it's 8/16. Right? That's the same thing as 1/2. Then get a common denominator of 16. So it's 4/16. And then a common denominator, multiply top and bottom by 2 to get 2/16. And then plus 1/16. All right, so have all denominators of 16. I'm going to add the numerators. 8 plus 4 is 12, 14, 15, 16, which as a decimal is approximately 0.94. And then finally, the partial sum of the first 5 terms. So I would need to have common denominators of 32. I'm not going to take the time to do that this time. So it's just 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. And that's going to give you a decimal of approximately 0.97. Okay. So step 1 is to find the partial sums. That's what I did here. Then we need to graph them. Okay, so step 2 is to graph. All right. So when I go to graph, I'm going to set up my XY axis. I'm going to have n as my x-axis and S sub n as my y. So I'm talking about 1, 2, 3, 4, and 5 being the n values. S sub n, So I can see it's everything from 0.5 all the way up to 0.97. So it's kind of up to you what you want to count by. Maybe I'll count by 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1. So count by 1/10. All right, so S sub 1 was 0.5. The second term was 0.75. Then I had 0.88 for the third term. Then I had 0.94. Then I had 0.97. Okay, so there's my graph. All right, so then it says describe what happens to S sub n as n increases. So as I was increasing my n value, right, taking the sum of just the first term, then the first 2 terms, then the first 3 terms, what is happening to your sum as your n value increases? Okay, you might say that your sum is also increasing, which it is, all right? But you can kind of see both by looking at the graph and looking at the values, right? We jumped from 0.5 to 0.75, which was an increase of a fourth, so right, 0.25. But then the increases become less and less, like 0.94 to 0.97, not a huge increase. And you can also see the graph is kind of flattening out. And that's because there is a limiting value, okay? What is happening is my sum is approaching, put that line there, is approaching 1. That's my limiting value. It's kind of starting to flatten out as it approaches 1. Okay, so S sub n, the sum, appears to approach 1 as n increases, right? It's approaching, it's kind of flattening out along there. Okay, so that's example 1 for today. Let me get set up for example 2. All right. So before we jump into example 2, I do have some information to give you. Sum of infinite. The previous lessons, maybe the previous 2 lessons, I forget which ones, we talked about finding the sum of a finite series. But now we're going to look at finding the sum of infinite geometric series. Okay. Now you might be wondering, well, how do you find the sum of something that goes on forever, something that goes on infinitely, right? Infinite geometric series. And we're going to talk about that. So first, let me give you the formula. S is equal to a sub 1 divided by 1 minus r. Okay, so we're going to be using that. Now there are conditions. All right. Provided that your r value is less than 1. We're going to talk about why that has to be true. All right. If the absolute value of r is greater than or equal to, then the series has no sum. Oh, I forgot the 1. Sorry, that doesn't make sense. All right, so if the absolute value is greater than or equal to 1, then the series has no sum. Okay, so let's look at an example and we'll investigate all of that a little bit more. So example 2, it's going to say find the sum of each geometric series. 3 examples for us. First example, lower limit of 1, upper limit infinity, and the rule is 3 times 0.7 raised to the I minus 1. Second example is 1 plus 3 plus 9 plus 27 plus ... And I think I'll have to wait off on the third example because I'll be smushing it. So I'll do C in a second. Okay. So for the first example, now you need to recognize the rule. It is geometric, right? Here is my first term, a sub 1. Here is my R value. So first thing you need to do before you jump into finding the sum is make sure you can find the sum. Remember that R has to be less than 1, the absolute value of R. So don't worry about negatives or positives. Is the absolute value of R less than 1? Yes, 0.7 is less than 1. So then I can find the sum. The sum is going to equal the first term over 1 minus R. So it's going to be 3 over 1 minus 0.7. Okay? And that's going to be 3 over 0.3, which is equal to 10. Okay? Now for the second problem, it's written differently. Okay? Now we can figure out what the R value is by looking at one term to the next. So first off, what is the R value? What am I multiplying by each time? You're multiplying by 3. So I know my first term is 1 and my R value is 3. Now stop before you jump right into using the formula. Is there a sum for this problem? Remember, R has to be less than 1. The absolute value of R has to be less than 1. Is that less than 1? It's not, so you can't find the sum. Now why? Why could I find the sum here, but I couldn't find the sum there? Notice that these numbers are exponentially getting larger, right? And they're getting larger and larger and larger and larger. As it gets larger and larger, because the R value is greater than or equal to 1, the values are going to continue to get larger. There's no limiting value. There's not a value that this graph, if you think about it graphically, there's not a value that it is approaching. So when the graph looks like this, if I was to graph the points, right, there's no limiting value, I can't find the sum. But if I was to graph the data here, there would be some kind of limiting value. It would be flattening out, so I can find the sum. Okay, so for part B, or for B, I'm just going to say absolute value of R is greater than or equal to 1, so no sum. All right, we have one last problem for example 2 before I move on to example 3. So the last one is, this was C, I just ran out of room. 1 negative 3/4 plus 9/16 negative 27 over 64 plus ... Okay, so figure out what is the common ratio. All right, bless you. You're multiplying by negative 3/4 each time. All right, so your R value is equal to negative 3/4, and your A value, A sub 1, sorry, is equal to 1. Now, since the absolute value of R, which would just be 3/4, since it's less than 1, there is a sum. Okay, the numbers are getting smaller and smaller and smaller, approaching some limiting value. So the sum is equal to, now I'm just using this formula, the first term over 1 minus R, 1 minus negative 3/4. Okay, so that's going to be 1 over, that's 1 plus 3/4, that's 1 3/4, which would be 4, 5, 6, 7 fourths, 1 divided by 7/4, and 1 divided by 7/4 is 4/7. Okay, so that is the sum. All right, last problem for today's lesson. All right, so example 3. Again, I'm just going to kind of read the directions so I don't have to write everything. I want you to write 0.242424 ... as a fraction. And of course, always write our fractions in simplest form. Okay, so I want you to write this repeating, non-terminating decimal as a fraction in simplest form. Okay, so we're actually going to think about this as an infinite geometric series. So step 1, we want to write as a geometric infinite series. All right, so think of it this way. Couldn't you rewrite 0.242424? Wouldn't that be the same thing as taking 0.24 and adding to that 0.0024? Look at that for a second. If I was to add those two together, oh, by the way, I should do dot. Just noticing I didn't do that before. If I was to add those together, right, you add that to those two spots, the 10th and the 100th, and you'd be left with that part of it. And then plus 0.000024 plus ... It continues to go on and on and on. All right. From there, identify your a sub 1 value, right? This is your a sub 1. Also, identify your common ratio. What are you multiplying by to get from there to there and there to there? Okay, and your common ratio is going to be 0.01. 0.01. Now, if you forgot, you might not be able to look at that necessarily and know that that's a common ratio. You can always figure out the common ratio by taking the second term and putting it over the first. So 0.0024 over 0.24, and then either simplify using your calculator or simplify using your head, whatever you want, and you're going to get 0.01. Okay? So now that I know my R value and my a sub 1 value, you can write the sum of the series. Okay? So step 2. You're going to write the sum of the series. Write the sum of the series. So the sum is equal to, and I left it up here, the first term, 0.24, over 1 minus the R value of 0.01. Okay, so that's going to be 0.24 over 0.99, which you can make into 24 over 99. And then both of those are divisible by, what did I divide by? Hold on a second, I think I made a mistake on my notes. Oh, no, I didn't. I'm sorry. All right, so I thought I made a mistake earlier on, but I didn't. All right, so it simplifies to 8 over 33. Okay. And that is that. All right, so that is the end of lesson 8.4. Join me again tomorrow for lesson 8.5. Bye.